Welcome everyone on another exercise from the workbook Statistics, this time focusing on the topic of probability theory. Let's have a look at our exercise here. In this case we have Hans commutes with his car between Wuppertal and Dortmund. Regularly, traffic jams occur on the highway. The probability that a traffic jam occurs in the morning is 23%, while in the evening the probability is 4%. The probability to be in a traffic jam in the morning and the evening is 2.5%. Our tasks now. First off, what is the probability that Hans gets into a traffic jam in the morning or the evening? Second, assuming in the morning a traffic jam occurred, what is the probability that there will also be a traffic jam in the evening? Finally, when you meet Hans in the evening, he is delayed due to a traffic jam. What is the probability that in the morning he has been in a traffic jam as well? Well, let's take a look at these three parts step by step. First off, what we want to have is the probability that he is in a traffic jam in the morning or the evening, or both. Statistically speaking, the or is always inclusive, meaning either in the morning or the evening or both. Here we just shorten this morning M and evening E. Well, what do we have from the exercise text? We know the probability that there's a traffic jam in the morning and that there's one in the evening. We also know that there's a traffic jam in the morning and in the evening, which is just 2.5%. Well, with this information, we can directly use the so-called addition theorem to calculate the probability we are looking for. The addition theorem is always used, or almost always used, when we're actually calculating a probability of the union of two events. So if we're asking the or question, morning or evening, that usually means addition theorem. And the addition theorem looks as follows. We have the first probability plus probability of the second event happening minus once the probability that both events occur. Well, here we have all these three informations already from the exercise, so we can insert them into the formula, giving us as a final result 24.5% that Hans will be in the traffic jam in the morning or the evening or at both times. Well, that was already part 1, so let's continue with part 2. Part 2, what we are looking for is a conditional probability. Under the condition that he has been in a traffic jam in the morning, what is the probability that he will also be in a traffic jam in the evening? Well, for this, we could use the formula for conditional probabilities, but first off, what do we know from the exercise? Well, we know the probability that there's a traffic jam in the evening, which is 4%, that there's a traffic jam in the morning, which is 23%, and we also know that there's a traffic jam in the morning and the evening of 2.5%. With those information, we can use the classical formula for the conditional probability, which is just this probability divided by the conditional probability. So here condition is about PM. So we divide this by event M. So we divide by P of M, probability of a morning delay. Well, so what we're going to do here is take the 2.5% and divide them by the 23%, giving us a total result of 0.1087 or 10.87%, meaning that if there has been a traffic jam in the morning, for roughly 10-11%, there will also be a traffic jam in the evening. Well, that was already done as well, part 2. So we can continue with the third and final part. Here in the third part, we are also looking for a conditional probability But now the two events are actually switching places. So now we're looking for the event that the evening train has been delayed or is delayed. What is the chance that the morning train also has been delayed or traffic jam has occurred? Well, again, we have the probability of the two events happening separately, and we know from part B the exact opposite probability, opposite conditional probability. So here we have M under the condition E. We know from part B E under the condition M. Well, why am I noting this? Because that's all the information we're going to need for the theorem of Bayes. And the theorem of Bayes is something we can always use if we actually are going to switch condition and probability. So if we're going to switch those two parts, and we already have the other conditional probability from an earlier exercise or from an exercise text. So here, this is a good application for the theorem of Bayes, meaning we're going to take the formula, which is just here I have M under condition E. So here I'm going to put E under the condition M times probability of what has been the condition here divided by what is the condition in the situation I'm actually looking for. Well, if we insert the values we just noted up here, we get this partial result and as a final result 62.5%. So there's a 62.5% that if the evening train is delayed, the morning train also already has been delayed. Well, that's then the final result for the third and final part. So this concludes the exercise, which I hope you enjoyed. And I say goodbye and see you next time.